Hello Year 12, Sergey, Jeffrey, hope you enjoyed skiving today. You'll have plenty to catch up on, do not worry. But for tomorrow's lesson you need to know about something called the definite integral. Okay? So, if capital F of x is a function such that f primed of x equals little f of x, that is to say, if you differentiate capital F, you get little f, we say that the definite integral, the integral from a to b of little f of x dx is equal to big F of b minus big F of a. Okay, now this idea of limits a and b is completely new, but please make sure you have this written down and put into a big special box. Right, it's definitely going to be easiest to try and learn this through an example. So here we have the integral of a function x with respect to x from the limits 3 up to 4. And from our formula, that says that the integral from 3 to 4 of x should equal the antiderivative at the point 4 minus the antiderivative at the point a. Well, we know how to integrate x. We get x squared over 2 and plus a c. Now we need to actually evaluate this at the points 3 and 4, and the way we write that normally is with a square bracket with a 3 and a 4 on the right hand side. Let me just shrink all this down. So when I say evaluate, that means we actually need to substitute in the numbers 3 and 4, with the 4 coming first. So we get 4 squared over 2 plus c, and then our formula says minus f of a, so minus the function at the lower limit, so minus 3 squared over 2 plus c, which gives me 16 over 2 plus c, minus 9 over 2 and minus another c. This minus will hit both terms in this second bracket. So these c's are actually going to cancel out. And what you'll find in all definite integrals is that the constant of integration cancels out. And in fact, as you get more comfortable, you won't even bother to write it because it will always cancel out in a definite integral. So now we just need to tidy this up slightly. 16 over 2 is 8, minus 9 over 2 gives us a final answer of 16 minus 9 is 6 plus 1 is 7 over 2. And you'll notice that unlike indefinite integration, our answer is actually a value, 7 over 2. It's not a function of x anymore. When you do a definite integral, your answer should be an actual value. So let's look at a second example. We want to find the definite integral of x cubed plus 4 from x going from 0 to 10. So the first thing we need to do is integrate the function. And integral of x cubed is x to the 4 over 4. The integral of 4 is just 4x. And I'm not going to bother to write that constant of integration because I know from that previous example, and you can convince yourself, but I know it's going to cancel out because you'll have the constant of integration at the upper limit minus the same constant of integration in the lower limit, and it will just cancel out. So I'm not even going to bother with it. But feel free to convince yourself it will disappear. So I need to substitute in the values. So the top value 10 first. This becomes 10 to the 4 over 4 plus 4 times 10, which is 40, minus 0 to the 4 over 4 plus 4 times 0, which is 0. So 10 to the 4 is 10,000, divided by 4 is 2,500, plus 40. And this entire bracket is actually 0, so I don't even need to worry about it. So my final answer, again, is a number, not a function of x, is 2,540. And that's my final answer. And you can actually check this on a graphical calculator, and I will show you how to do that now. So here is how to work out a definite integral on a graphical. Nice and easy. So check you can use your graphical calculator for the first question as well, and I'll see you tomorrow.